We are geotechnical engineering student. Today we came at Dubri to for site visiting in Argul Sukinda railway project. And today we see here how geosynthetic use for slope stable.
So here we will see the drawing of the cross section of the retaining wall of the Gaussian box with boulder packing. So and with the geogrid and geotextile, how what the specification dimension and what the mm, alignment here. So we will see this is the railway track level, and this is the sump of the drain. Below the track level, then the breast wall or tidal wall, there or it boulder packing, and then yeah, we will start here. At first, in this below above the track level, but below the existing ground level of the track level, they provided for rigid foundation. Okay, 1.5 meters, 0.2 meters height, and then they started the track, the Gaussian box of the synthetic and boulder packing are done. 16 point 6 mm up to 6 mm boulder stack here. Not 6 mm. So dimension 4 meter, 1 meter, and zero point 0.5 meter. The wide is 1 meter, height is 0.5 meter, and length here you can see length here, length here. Every um, every box is 4 meter, and one box or overlap below lower box 0.2 meter only, and the overlap with two given box below. So here uh, and 2 meter overlap. And this wall height is 6.5 meter, and different tensile strength geogrid with different color here drawing. So different up to they are provided have provided 15 layer, and 1 to 6 layer 16 kilonewton per meter, and 6 to 9 layer 80 kilonewton per meter, and 100 kilonewton per meter 3 layer, and 120 kilonewton per meter for 3 layer, because our pressure will be increased when respected to depth of the soil and of the slope. So they provided geotextile. It is provided to bearing, also pull out. Here only pull out register to prevent the pull out failure, and also the bearing from upper layer to lower layer. So and here it attached with Gaussian box, and 1 meter overlap, wrapping here upper side, and non-open geotextile provided here to not connected the fine soil to Gaussian box. Uh, so yeah, the water level existing the water level is the first burn wide 14 meters, but here geogrid provided 12 meters, and every layer is 0.5 meter, 500 mm, and but in this is the reinforced wall up to 12 meter reinforced soil, and 2 meter unreinforced soil. In unreinforced soil, and yes, it is unreinforced soil, and up to 12 meter reinforced soil, and then again after 2 meter uncontrolled cell, then again constructed second one, and each layer 0.5 meter, again same height of the 6.5 same Gaussian box will design it. After that they provide it, and third one along the ground level, so provided 3.5 meter, but all Gaussian box same dimension, and followed the here the geo grid length 6 meter. Okay, here the geogrid across the third bound. Okay, across the third one. But here unreinforced soil provided, here reinforced soil provided, and again here 6 meter, but here some unreinforced soil provided. The backfill is also told it in the existing backfill material. Okay, the soil, the silty clay soil or whatever exists in this area. So we'll see it. And here we will see the here we will see the how geomet provided to protection the slope. So geomat with geomet, geonet, geomet and turfing and attached to J hook. So here the top anchor, here top anchor provided to fix the mat or geomet and anchor 2 meters, 51 dia of the drill hole and grouted it and 32 the bar. First drill and the bar drill it into the hole and they grouted the hole, fixed it. And here the we can see the mechanical woven double twist hexagonal set wire mesh at 10 to 12 and wire mesh dia 2.7 3.7 mm. And also at first prepare the slope, the 2 is to 1 in this one and in this one 3 is to 1. So after preparing the slope, they attach the geosynthetic mat, high performance turfing geosynthetic mat, and then they along attach the along the geosynthetic mat along attach the geo double twisted hexagonal shape mat. Here two geo mesh stitches the cleavage wire and lacing wire. Okay, with single loop and double loop. And also we see that there the perforated PVC pipe provided for perforate the water from the existing layer and to prevent the pore water, reduce the pore water pressure, prevent the failure of the slope and level the slope. So these all pipes, how they provided. Uh, this pipe 4 meter vertical and 5 meter spacing. Okay, and two row, and these two row and 4 meter to 4 meter and 4 vertical and horizontally 5 meter spacing. This is 4 meter and horizontally vertical spacing and 50 diameter PVC pipe, 8 meter along half perforated depth. 8 meter. This is 8 meter. So 8 meter long, 8 meter long and 50 diameter wrapped in non-geotextile, non-woven geotextile and 10 hole provided 20 center to center for perforating the water through this pipe and it is to go through the water go through the drain and their weak hole provided. Weak hole are also provided to perforate the water, keep it in water because groundwater level is very high. So this net or mesh is the bomb weight 3 meter. This net or net or mat or net is attached to the soil through the jet. You can see the jet dimension here. So jet provided, and here this green color indicates the grass to protect the slope and the mat material. Yeah. So they are discussing the how slope. So here we will see the what is the soil condition in this area. So we can see through the soil geotechnical soil investigation, and so they provided already testing provided the SPT test and they provided the result. In this area, the seismic zone is 3, and we can see as the interchange level, the maximum depth of exploration 28.5 meter and groundwater table in 1 point and 2 meter below EGA. So we will see And at this canal, various depth is at different depth, and the SPT value with undisturbed soil, the disturbed through the core barrel, and again the undisturbed soil have taken, and they after so many parameters tested through the lab, and they provided the soil strength at 1.5 meter depth, 16.55 ton per meter square, and 3.0 meter depth at 3.3 meter depth, the soil have strength, bearing strength, 39.58 ton per meter. And at this level, 1.5 meter depth also settle in the 69 mm. It can be happen up to 69 mm as per lab test. And step bearing is, and for settlement of 25 mm, and the step bearing is 6 ton per meter square. And up to 4.5 meter, you can see at the level of 4.5 meter from the ground level, uh, net step bearing capacity is 25 newton, 25 to 1 newton per ton per meter square. Settlement 44. So here, as per 25 mm settlement, so the step bearing pressure we can apply here the 40 ton per meter square. So as per according to the soil strength parameter IS 6403/1981, and settlement criteria as per 8009 1976. So we'll see that at CNH, we see the investigation report. Investigation report has rotary boring. Rotary boring was conducted, and dive boring 150 mm and inclination vertical. The groundwater table was found 1.5 meters below existing ground level. So here the they through the SPT, every 1.5 meter they taken the sample. Every 1.5 meter they taken the sample and SPT number. SPT blows number. Here three layer 150, 150, 150 mm. 15 centimeters. Last 300 mm, 130 cm layer the blows counted here, and take this total penetrate the rod, the 1.450 as rule of the SPT testing. So here, if we 1.5 meter, they classify the soil type of soil. So at first clay sand, then up to 3 meter, they found the silt clay with medium compressibility, and then the soil silt and clay with low compressibility. Low compressibility. Uh, Also plastic, plastic, and also low expensive, this type of soil, and also medium compressibility, and then again up to 6 to 12 meter silt clay and low compressibility, and all the color of the soil brown, and the soil sampling criteria have provided disturbed soil, undisturbed soil, SPT value only taken, then undisturbed soil, then again SPT value. So they are every different type of soil identify this type of scale, this type of different type of scale provided. Another borehole also uh, in same borehole. After here we see the up to 15 meters from ground level. Here we see this the 15 to 28.5 meters. So after 15 meters, the silt clay with low compressibility and SPT value greater than 50. Up to 50 meters, up to 12 meters. This is corrected in SPT in value. So up to 12 meter is 49, and after that greater than 50 meter, and also after 28.5 meter that is greater than 100. The greater than 100 SPT will non-required. So here something found at different types of soil, whether sandstone founded at level of the 24 meter to 25.5 meters from the ground level. Some weather sand found it. And all are silt clay and low compressibility. Maximum silt and clay with low compressibility. So we'll see the what the result of the left is here. We'll see here. So we can left this result in this area uh, soil. So different type of you have fine grain, the grain size analysis, Utterberg limit, uh, grain size analysis, the coarse, fine, different type of size of sieve used here. To up to for silt clays have 0.07 mm to 0.001 mm, and up to you know, 4.75 to 0.075 mm to sand, and greater than 7.5 to 4.75 is the gravel. So gravel found to less percentage. Maximum percentage is sandy and silty. Silt percentage is greater than 50%. Here you can see silt percentage greater than 50%. All the silty and clay. It is silty and clay. Here plasticity. Plasticity always greater than 10 up to 16. Here you can see plasticity index. So not more plastic, it's a medium plastic. Here field moisture content 14 percentage, and bulk density 1.82. So silty material, maximum silty material, so 1.88. So this gum per cc bulk density, and dry density 1.60, 1.64. Dry density in gram per cc. Silty clay for silty clay. Cohesion also found it at this level 1.5 meter. They found the cohesion in the soil 4.44 kgA per cm square. And also angle, the angle rate of the shearing resistance in degree 15 degree. So angle of shearing resistance 15 degree are founded. Specificity 2.67, 2.73, maximum 2.77371, 2.7. There are also void ratio found in the 0.71, 0.63, and free soil index. Free soil index greater than 20, 25, not much expensive, not less than 50. So medium expensive, low expensive, not expensive soil due to field. Here field SPT value also provided the SPT result from the result and summarized, and also classification of the soil, clay soil, clay soil, clay low compressibility, medium compressibility, low compressibility, low compressibility, CL, medium compressibility, CI. So they also sandy, sandy clay free. So we can and see the how classification of the soil through that code, and also we'll see the how they calculate it. And they taken the to calculate the settling and bearing capacity. Seen that already seen that bearing capacity and, settlement. So there are cohesion parameters. They take cohesion parameter 40.44 per semester, and shear angle 5 angles and corrected angle 10 degree. So void ratio 0.71, and capability take 2.73, and submerged density, and then we calculated after void ratio and capability, the submerged density is calculated here, uh, and depth up to 1.5 meters, and they are assume the at first take the length of footing and width of the footing in here, yes, length of foundation, length of foundation. So width of foundation here, and then calculated the bearing capacity factor in the at respect angle of resistance. The find from the ice code or 6403 ice code 6403 mentioned in this report. So from collected there the NQ value and ground value, NQ value, and then SP, and there are some formula as per according to code, ice code. So SP value, some factor, that factor, and also depth factor, also affects the ground water table above the footing level. So take the up to surface of the ground level, you can take 2.50 most condition, and then the general level you have to consider, and formula for this formula for this type of bearing capacity measuring. This formula completion by iFood is 403. So and then measure 8.21 kg per centimeter, then converting to ton. For local shell failure, 4 point, and they put in the formula the two third of the C two third of the cohesion, two third of the phi angle. So we have local shell failure reduce 4.53. They here have taken the spectral 53 and then bearing capacity and calculated 16.555 ton per meter. So, and we will see the consolidation how they measure it. Okay, so also we will see the higher after depth of foundation, influence zone 4 meter, and the site foundation we have taken. So impose the load bearing capacity or measured it. Okay, calculated it. Submerged density 1, approximate 1, high compressible layer 4 meter, taken every 4 meter compressible layer. So initial compressive index through the consolidation test, so we can measure it, volumetric test. So then measure it, and initial pore pressure, area of the footing, taken initial pore pressure, initial pressure. So initial pressure means only soil pressure, here 3 point overburden pressure. And so my area of footing, and then we calculated the height of the layer, void ratio, and compression index, and initial pressure, and applied pressure. There, as per I scored 8009 part 1 1976 as per clause 9.22. So the formula already have given, and so take this formula and calculate it, and settlement found 104.6 mm. So also calculated the settlement, immediate settlement after foundation, found as soon as possible after foundation. We calculated the modular elasticity of the soil, influence factor, from this, from the code, and calculated the immediate settlement after. So less 4.72 and 104 mm total settlement 109 mm. So very high 109 mm settlement. So here the depth factor. So for you reduce the depth, so depth factor will have to apply, and for rigid foundation and for rigid factor need to apply that. So finally their perfect factor multiply with this total settlement, and the final settlement can get 68.7 mm. 68.7 mm we take here. So as per 68.7 mm, so we'll, so after, and then they calculated at depth of 3 meter and depth of 4.5 meter, and also so depth of 4.5 meter and 44.4 mm settlement, final settlement at 4.5 meter. So here already told you that the settlement calculated 69, 79 and 4.4, 44 mm, 44 mm, and then as per 20 mm settlement, what the bearing pressure we can apply it on this soil. So soil surface. So we calculated it. So see the how the SPT corrected in value to add in depth. This SPT value first 1.5 meter, then 3 meters, 6 meters, and okay, graph like this. Also grain size, particle size, and also percentage of the fines, percentage, and they or as per depth they change the color and design marking, different type marking. So soil their grain size, curve, logarithm curve, which is a semi logarithm clarify the very visually clarify for this the logarithm curve we can consider, and also see the how to calculate the cohesion and triangle at laboratory through this graph. So we can conduct the direct test on the soil. Mm, so here normal test applied, uh, 1 kg per centimeter square, 2 kg per centimeter square, 3 kg per centimeter square. Then where failure involved touch the tangent point from three applied normal test and connected with one line and get the find with the find. Also C value from here 44.44 kg per centimeter square. Also this 0.44 kg per centimeter square and 5 angle is 15 degrees. So we can plot it in the graph after collecting the data from direct axis and calculate the bearing capacity of the soil, settlement of the soil from every depth. They calculated the cohesion and angle of resistance, SPT, how they constructed SPT. Now they, um, yeah, today the how slope failure or how the constructed and to prevent the slope failure on the happened failure, sliding and failure slope in to the railway track, how they constructed. So this is here the slides of failure and sliding and to the railway track. This is the railway track which are constructed only through the mm, through locally during rainy season and June time in rainy season at Jajpur on Odisha. So we will see how they realize and reconstruct to prevent the slope. Here, after previous construction, they only provided the retaining this wall to retain the and provided the berm 3 steps in 3 steps provided them from ground to well track level. But during rain season, due to poor water pressure, they not stable the failure in on the railway track and sliding the slope. So after slope, we have to construct it for constructing and to prevent the slope failure and to stabilize the slope. They reconstructed here. Then they are benching the soil to transporting the vehicle and material and for excavator for excavating soil from the railway track and then excavate and benching and removing the existing loose material, loose soil. This is the sand and silty soil is already discussed. So here this soil is removed from here and then they have constructed. Here the seed pipe here provided and remove from the soil on from the remove the soil from the railway track because quick construction in the railway track to run the train and then they have constructed the everything slope wall the box. So we will see next. Here, after filling the flow, so we have to reconstruct it and refill the existing structure. So here we see the Gabion wall box provided. Gabion wall was provided the first berm constructed and to stable the slope uh, from distance the base wall to some distance from base wall to mm, uh, uh, Gabion wall box and they constructed with geogrid. Okay, geogrid and they started to prevent the slope from poor water pressure or pressure, stable the slope. Here we can see that the the between sheet pile and this wall they pack the boulder up to 600 mm boulder pack here for drainage water. Hmm. Pour the water and then the water also fill the fine soil here is pouring pour here. So mm, and then here then they constructed and here the wall was prepared the stable slope. Here we can see here. So after prepare the blast railway track and also assemble the signal and telecommunication electricity and then constructed then the started the Javian wall was retaining wall. So they first remove the loose material what have already fluid and they started the Javian wall and continuing their construction. Yeah, at the existing ground level or railway track level below the railway track level below the existing ground level. So first they at below they have we can see in drawing the provided foundation and they provided the gabion box with boulder gabion wall facing with boulder packing. So boulder pack in the box of the geonet that have also provided. And this is every box is 2 meter length and 1 meter wide and height 3.5 meters. So and each box overlay with each another two box for every layer 2 meter overlap and this geotextile provided along vertical of the wall uh, to protect the separation or prevent the so fine soil to penetrate in gabion box and also protect the seepage if any pour water or seepage protect the permeable in the gabion box. So uh, and then fill the existing materials and also fill and every layer and they're compacted by roller in this the side of the slope. Mm, yeah. After provide the gabion box stack after stacking uh, each on another and every layer. After one layer, they attach the geosynthetic the geogrid with the gabion box and each layer different tensile step and of the geogrid provided at different level. So they have geogrid attached with the gabion box due to uh, stable of the wall. For stable of the wall, not slide any more. Have to be consider the length after designing mm, to, to protect the pressure from facing up to the length provided and designed. Here, the laying of the geogrid, perpendicular direction of the uh, direction of the failure of the sliding of the slope. So, and they are manufactured in a fixed wide. So they teach fixed wide and they teach is to roll of the geogrid. They teach here. And after compacting the filling material, existing filling material, and then we provide the geogrid, and then we will fill here again the next layer. So you can do this is biaxial geogrid, and also so here we will see here here the track level into the blast, and then pump or drain down the track level downside, and then the wastewater there have boulder packing and here 0.5 meter height every judgment box and then slope 6 degree angle. and they constructed first berm of the slope, and each layer provided the geogrid, along vertical layer provided the geotextile. Here the second berm will constructed at some distance, at some distance. The second gathering block started. There, at first they provided the foundation, usually of the concrete, and then started the gathering block stack in one another, and then and with the geogrid along the slope of horizontal. So this is the second step, and this is will be first step. First we will see how the one barn to second barn constructed. I will see. Also, we can see as a PVC pipe, perforated PVC pipe provided. Perforated means some hole in the PVC pipe, and then PVC pipe provided in along the slope horizontally. Um, so, to permeable or seepaging water pass through the PVC pipe, and it will be connected through the drain. Um, it will be helpful, beneficial at the during rainy season, or groundwater level is very high. It is permeable through this, perforated through this pipe, compared to here. We will see the first berm constructed. Okay, first berm constructed here. There's some difference there. Second berm will constructed on this area. So for to prevent the water seepaging through upper layer to lower layer, so they provided the composite geotextile, geocomposite geotextile, among one geotextile provided here to prevent the seepaging from up a lower layer to upper layer. So whatever constructed from existing layer, what nature will count it. So here you can see the perforated, also not perforated, this is pipeline, in pipeline, PVC pipeline connected with the existing slope, and the water from this existing soil will pass through this pipeline and to the drain. So at first they laying the geotextile, and then we constructed second one. Yes, this is a geocomposite or non-woven geotextile with non-geotextile which along the vertical wall of the soil, existing soil. So and then constructed here the second one will constructed, and this is the PVC pipe with wrapped with the non-woven geotextile, and connected it with this the behind the geotextile, and water behind the soil will pass through this PVC pipe to drain. So and here we'll constructed the second one. So we can see here that the three bumps, one, two, and three bumps provided to stable this slope, steep slope. This is steep slope. Hmm. It has failure. The failure due to poor water pressure and during rainy season. So they are left hand side, and this is the right hand side. So left hand side at first constructed, and then they started the right hand side. So here geo meet the turfing geo met and turfing geo high performance turf reinforced geo mat with geo mesh. They constructed to prevent the soil erosion and also stable to from the rain water, and the existing slope. It has not failure, but in this area soil slope failure happened. For this reason, they again construct the Gavin wall, retaining wall. So yeah, the geo mat, this turfing mat, also in the turfing mat, PVC pipe also, we see the drawing, PVC pipe also provided for percolate the water and to the drain. So for stable, reduce the pore water pressure in the soil. Also, grass is provided to protect the damage of the net. Also, soil erosion and from. This is the track line, this is the drain, this is the breastwall, and they will packing, then pit file, and then protect the soil to prevent the failure of the slope. Provided canal blocks, up to every layer have provided geogrid and oil geogrid with the 15 layer of the soil. Slope and then again same avian box wall retaining wall and then third barn constructed here the geotextile provided to present the pore water or sand material into this have fill the existing soil whatever there at first construction and the nearby above the hill so that's why the groundwater level also high 1.5 meter which is quite okay. So this is the all constructed picture whatever constructed to prevent the uh, failure of the slope steep slope it is a steep slope for this reason the boulder packing gap was provided.
All geotech batch guys came for the site visiting, filled how to use geosynthetic slope and just one can I explain yeah.
Now we
Okay.
came to second site visit.
Second site visit.
It's like stone pitching here. And is here there are two tracks.
Here the slope constructed with geomat and grass turfing and here erosion control and stability. So also here the stone pitching have provided and here you can ask the vegetation is geosynthetic. Here a railway line constructed in a hill area. You can see here gabion wall provided for sloping, slope stability, and slope stability also provided with here geomat with soil nailing. Here some slope about 20 meter, 10 meter, 10 meter horizontally and provided approximately 10 to 15 meter inclination this wall. In this wall they constructed with a layer. Here each layer they are provided geo grade and all. You see at the approach of slide slope they are provided the boulder to prevent the erosion control and also they provided the geotextile for separation and penetration of the fine material into the gabion wall box and so the Rajkumar something explain here. तो जियोगेट का लेयर के हिसाब से लगाया बताओ और
नीचे का जियोग्राफी बहुत स्ट्रांग है तो डिक्रीज स्ट्रेंथ इज डिक्रीजिंग व्हेन वी आर गोइंग ऊपर
again provide because what groundwater table is high than this level so and other thing if rainfall
जियोग्रेड तो 120 किलोमीटर पर मीटर स्ट्रेंथ है और 90 है 70
yeah
60 तक है।
अच्छा ये वीपुल किस लिए किया है
ये तो ड्रेनेज के लिए किया है जब भी बारिश गिरेगा वाटर सीव करेगा तो ऊपर से इधर नीचे से पानी आएगा
ड्रेन ड्रेन में पानी आएगा एंड वो ग्राउंड वाटर टेबल यार हाई ना
ये ग्राउंड वाटर टेबल देखो अभी देखेंगे तो इसके ग्राउंड वाटर टेबल के पास हम पहुंच गए हैं इसलिए ये फॉरवर्ड प्रेशर ज़्यादा होने का चांस है इसलिए
स्टेबल के लिए तो गैबियन वॉल बस
ये तो ऑलरेडी कोलैप्स है इसलिए मतलब वो ट्रीटमेंट के लिए गैबियन वॉल से कर दिया उधर तो सेफ के लिए अभी तो जियोमेट लगाया अगर उधर भी कोलैप्स होगा तो उधर भी गैबियन वॉल डाल देंगे
and opposite side we can see the here that in here collapse slope this slope is under testing. This steep slope, and this side, left side, and you can say this is gentle slope. It's can stable without any wall, and they have provided the geo mat. You can see their design, and this design you can see, and also provided geo net with on the mat, and they are stitched with the soil nailing. Here you can see this nail is provided whole along length and some distance space with some distance space, and it is provided for only soil erosion control, and also control the pressure, low pressure of the earth wall. And here you can see they are provided there's this pipe with a geotextile, and because they are something for water the seepage, and some for water seepage, and rainwater can exit from with through this pipe. So two geonet stitch like this type of with a geonet part, one geonet wire, so up to upper slope to lower slope, geonet provided this alignment. Also you can geo mat, this is stitch like this, and also same direction with geonet. Here guided to retain the earth pressure, and then constructed this line. Because the line level very low, up to ground level, from the ground level. So at first they provided seed pile, and then excavate, and then constructed this type of retaining wall. And there you can see the we fall in the wall, because there's something rainwater can seepage and through this permeated through this the boulder layer. And you can see also there's something water groundwater level so high, this you can see the water seepaging through this borehole, we fall, and some wetting and some seepaging. You can see this steep slope and collapsible under process of the testing, and then they provided this gabion box wall and for stability. So